Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Introducing RudderStack Profiles. RudderStack Profiles takes the SAS guesswork and SQL grunt work out of building complete customer profiles so you can quickly ship actionable, enriched data to every downstream team. You specify the customer traits, then Profiles runs the joins and computations for you to create complete customer profiles. Get all of the details and try the new product today at dataengineeringpodcast.com/rudderstack. You shouldn't have to throw away the database to build with fast-changing data. You should be able to keep the familiarity of SQL and the proven architecture of cloud warehouses, but swap the decades-old batch computation model for an efficient incremental engine to get complex queries that are always up to date. With Materialize, you can. It's the only true SQL streaming database built from the ground up to meet the needs of modern data products. Whether it's real-time dashboarding and analytics, personalization and segmentation, or automation and alerting, Materialize gives you the ability to work with fresh, correct, and scalable results, all in a familiar SQL interface. Go to dataengineeringpodcast.com/materialize today to get 2 weeks free. Your host is Tobias Macey, and today I'm interviewing Vignesh Ravichandran about building an internal database as a service platform at Cloudflare. So Vignesh, can you start by introducing yourself?
Thanks, Tobias. Thanks for having me. I'm Vignesh, currently working at Cloudflare as an engineering manager, building the database platform for Cloudflare. Started at Cloudflare in 2019, so it's been now almost close to 4 years. Joined the team as a founding engineer, individual contributor, obviously, working on helping them build the database platform. Earlier, it used to be a generic SRE team, which was managing all the Postgres databases. And last year, I've transitioned to leadership role, and I'm currently managing a team of six database engineers who are located all over the world. And our team is using the follow the sun model. So I have team members in Europe and as well as Asia. For most of the time, I have been just fiddling with Postgres, and before Cloudflare, I was with Ticketmaster, which is an online ticketing company, pretty much running ticketing events for NFLs, NHL, and pretty much any high-profile events. And yeah, that's been my focus, mostly just databases, and recently it's all Postgres.
And do you remember how you first got started working in data?
How I first got a interesting. It all started probably 10 years ago. My very first job right out of the school is an Oracle DBA. So that's database administrator. It's a role used to be there for 10 years ago. I'm not sure how much it's still relevant, and that's how I got into database field. It's more of an accident, I would say, because almost all my schoolmates, they all got into application development. Like they were all interested in either Java, .NET, and other frameworks and other programming languages. And I kind of stumbled upon into Oracle world, which I believe. I mean, I realized that it's a surprising one because a lot of the DBA roles require prior experience. Like so, that's how I got started.
And now, talking about the work that you're doing at Cloudflare, can you start by just describing some of the different ways that database workloads manifest within the company and some of the types of challenges that you're faced with trying to maintain the health and reliability of those databases?
Yeah, so Cloudflare's challenges is kind of fairly unique, I would say. That's what, to be honest, makes it interesting and keeps me, up in the night. One, the very first is Cloudflare doesn't run on any other public clouds. Cloudflare is a public cloud to a certain extent, and they have their own infrastructure. We have like points of presence all over the world, and then we have like kind of core data centers which are located in in a couple of regions or a couple of continents. Postgres runs on the core data centers, and again also it's all running on bare metal. So the Postgres that runs on Cloudflare is on bare metal. There is no abstraction between the hardware, the server, and Postgres software, which means no virtualization, no Kubernetes, and to be honest, there is nothing in between Postgres and the metal. So that's the first challenge, I would say. The second one is there's no like sleeping time for internet. There's no like downtime that you can take when you are working on the internet. There's always someone up, and there is always someone is going to notice if your services go down. So that's the very interesting challenge, because I didn't realize that to a pretty much good extent in all my previous roles and companies. We were able to take downtimes like, hey, okay, we are going to take shutdown this weekend and this night. That's not the case. So that kind of forces us to think anything that we want to do, like, hey, we want to keep our services up and running, but we also need to do this. How do we then now, go back and architect and engineering our processes? So that's the two unique challenges that I have found working on Cloudflare's environment.
And so, given the high uptime requirements and some of the data volume, I'm wondering if you can talk to some of the different setups that you've had to go through at Cloudflare to be able to manage that high uptime and the database throughput, and a bit of an overview about where you are now.
Sure, yeah, I can give you a glimpse of the scale at which we operate. So right now, Cloudflare pretty much gets like close to 40 million HTTP requests per second. So by now we are talking, it's already crossed more than 100 million requests. So that's the scale at which Cloudflare is operating. That's on the data plane, I would say. On the control plane, which is where our Postgres databases have located, which basically provides the support for authentication, authorization, anything related to control plane management, which includes user accounts, managements, user managements, profile creations, DNS records, configurations for R2, D1, D0, all the products, including Cloudflare Workers. All these products that we see at the front facing of Cloudflare is using a control plane Postgres database. And that's what my team provides and supports.
In terms of what you're building now, you've developed a database as a service platform within Cloudflare so that application engineers don't have to be well versed in the operational characteristics of the database. And I'm curious if you can talk to some of the requirements and design constraints that you had to account for in the process of designing the desired state, and some of the rough overview about where you've landed in the development of that platform.
Yeah, makes sense. So our we can start with the SLAs and SLOs, right? That's what pretty much derives how we build our platforms. Our service level agreement SLA for point in time recovery is zero data loss. There shouldn't be any data loss even in any disaster. So that's the requirement number one, first one. And then the next one is that recovery time objective. So how long it takes for our services to recover from a failure, which is currently under a minute. So which includes either Postgres is crashed, Postgres is running out of memory, a server goes down completely, the primary server, or even a data center went down completely. A complete data center goes down. We have to recover our services Postgres within a minute. So these two things derives a lot of what we do, and we can talk more on in depth on how we got there. But that's the fundamental requirement, and we trying to keep pushing them and whatnot.
And in terms of the database technology that you're using, obviously you are a cloud provider, so you can't rely on other cloud providers to be able to fulfill this very critical core service. But in terms of the actual database technology, what was the motivation and reasoning behind selecting Postgres versus some of the other options that are out there, even some of the Postgres derivatives such as Citus, or the work that they're doing at Cockroach, given the fact that you do have to manage this massive scale, global capabilities, etc.?
That's one thing that I'm very happy of. That one of the decisions that the core founders made, not to be honest, our team, not the team that is currently at Cloudflare. Since 2009, when the company started, it's been Postgres. From day one, it's Postgres. I'm so grateful that we are not migrating at some point in time from this X product or this X vendor to now to the open source Postgres. So started with Postgres. I still see some of the initial commits by the co-founders from 2009. So to be honest, I exactly don't know the reason why they picked, but I know some of the the ideas behind why they picked. Because one, it provides a good support, like data type supports for inets, like the IP addresses. They were like first class citizen in Postgres. So since we are dealing a lot with IP addresses, that kind of made sense. Two, obviously, it relates to how much Postgres was solid even in 2019. It made it so apparent that okay, we can rely on Postgres and build our business on top of it. So those are the two attributes, I think.
Given the fact that there are these other database engines, particularly things like Cockroach or Yugabyte, that have Postgres compatibility, with the work that you're doing to manage the database as a service engine and the fact that you're running on physical infrastructure, what are the reasons against moving to one of these other scale out Postgres compatible database flavors?
Yeah, I mean, first of all, credits to all of them who is stretching the limits or the boundaries of what Postgres can do, right? So kudos to them. I think the very fundamental reason, and also to be honest, this topic comes up often. Like, hey, I mean, engineers ask us that, hey, Vignesh, what's next in the database world? And I go back them just Postgres, and they are like, "Ha, disappointed." Like, come on, we are looking for to hear something more, more exciting, and we are like still sticking to the plain old Postgres. So the reason is one, the autonomy, to be honest, that we can change and do whatever we want with Postgres, right? Without thinking or without involving anyone else, right? Any other team, finance, legal, marketing, nobody, because we just use plain old vanilla Postgres. So the autonomy is, I would say, the biggest reason why we use Postgres. And to be honest, not just Postgres, a lot of the other core technologies that we use, Cloudflare, all follow the same pattern. Open source, no restrictions and licenses, a good community. Okay, we will pick that because it provides autonomous. I can go a couple of specific case studies where that really helped us. So it helps us, for example, like patch Postgres doesn't have to wait for another vendor to come back and gives us a validation. We go to the mailing list, talk about the problem, run it by some of the senior members of the Postgres community, and if we get a good thumbs up, we know that we are on the right track, and we go again and fix the software and get that validated, hopefully contribute to the upstream. So this is by far the single most reason why we picked Postgres.
And so, with Postgres as the core building block of your database service, what are some of the ways that that has simplified your work of only having to support one engine versus something like Amazon RDS, where they have multiple engines that they need to be able to run for different customers, and some of the ways that you've been able to optimize for Postgres in the development of your database service?
Yeah, I mean, lesser the number of software, it's simpler, as simple as it is nowadays. I guess we all can agree that developing software is becoming more complex than it used to be. One has to know a lot more than just get something up and running. So yeah, that's a very good side effect, I would say, of just sticking to Postgres and going back to the basics and asking the fundamental question of what are we trying to achieve, and why Postgres is not a good fit. And most of the time we came back, it's like either maybe our requirement is not right. We thought that, oh, our requirement is this and we have to do this, and then we went back like, not necessarily. Or two, even if we do come across some really interesting use cases, and Postgres has been able to stretch itself and able to lend. So those two things made it easy for us to, in terms of managing the number of components that we have.
Another aspect of what you're building is that you have to be able to support multi-tenancy within the database workload. And I'm curious, what are some of the challenges or complexities that arise as a result of that, and some of the ways that Postgres has either helped or hindered that effort?
Yeah, sure. That's interesting. And to be honest, to answer this question, I want to take a step back and give an overview or an architecture overview, and then explain why this is a problem, right? Because some of it is that it's avoidable, and we have kind of inflicted this problem on us. So we have the architecture at Cloudflare is kind of two core data centers where we have our Postgres databases have been located, and within that each region we have like availability zones, right? Like, so you have your US West and Europe East, And within US West, we have three availability zones, and there is one instance of Postgres running on each of those availability zones. And inside that one instance of Postgres, we have multiple databases. So we have like one Postgres installation, one process that's running, and there are like 20 to 30 other databases that's co-located on that same instance. We can take a step back and just think, do we need to do this? Why can't we just put one database per each instance? Why does one instance has to co-locate multiple? There are some good reasons. Let's say if two databases are kind of related, has some related data, then it's so much more easier to query the data if they both resides on the same instance. So that's the biggest reason when someone wants to kind of try to co-locate. Second reason is a little bit more towards bin packing, right? We're trying to be more efficient here. Hey, we run only one instance, but put more databases in them so that we can pack a lot more. I would also counter argue that you can get further by actually just sticking to one database per instance. There are some bit of overhead, right? Because each now database contains its own instances. That means you have to now build all the monitoring and the backups and everything now for like thousands of instances. Let's say you have 1,000 databases, that means 1,000 instances. Now you kind of like managing kind of a service oriented architecture or microservice based setup. There are pros and cons for both, but at least one of the cons with this bin packing approach of putting multiple databases at a single instance is performance isolation, or I would say multi-tenancy problems, or aka noisy neighbor problems. Any of them kind of represents the same. The idea is that one of your tenants is kind of unintentionally starting to impact the other tenant. I mean, we need to, underscore the word unintentionally. I don't think any of the applications here trying to intentionally sabotage your sister applications or your neighboring applications. And it's a lot harder to even first identify who is that noisy neighbor. It's like a zoo. One of my colleagues says that, hey, this is a zoo here, and one of the animals just started acting weirdly, and the engineers now need to figure out first who is that animal. Takes time. Then we have to controlling them is another task. So first we identified, let's say, okay, here is this one application which is not acting properly. Then controlling them is the next challenge. So keeping every one of them as a good citizens in a shared environment is a challenging task. And to a certain extent, probably I'm going to kind of do an hot take here. Hot take here. Postgres is not built for multi-tenancy. Postgres was built around 1990s, and then in those days the architecture, or whatever it's meant for, is that, hey, you just install one installation and you're not going to put anything other than that on that mission. So it's but again, it's not a promise that Postgres wanted to do or anything like that. So we just stretching it, and we are trying to kind of overcome some of the challenges that comes with it.
Digging more into the architecture that you've built and some of the driving factors, you spoke to the SLAs, SLOs, some of the requirements around the scale and throughput of the database, but I'm also interested in the developer experience that you're trying to focus on supporting and some of the ways that you've been building relationships with the teams that are consuming the database engines and how that has driven the ways that you think about what to optimize for, how to build the interfaces, and some of the ways that developers are able to get access to new database instances, whether physical or logical.
Yeah, this is becoming such a big topic. It used to be, it's like, hey, it's a black box. You create a Jira ticket or whatever service desk ticket, and then just wait for a week or two until someone comes back to you. That's the norm, or at least it was the norm when I very first started, especially in a Fortune 100 company. But this is gaining a lot more attention, that developers have really used to the feel of a cloud provider, and they do want the same even in-house services that they are using right now. Still, I think this is one of the areas that, to be honest, that my team needs to do some bit of work and to improve. Currently, anyone who wants a database, they go ahead and file a template that we have for the teams that has some fundamental questions like a do you want your database to be multi-AZ? I mean, to the most part, yes, almost all the time. Do you want your database to be multi-region? And we ask them some fundamental questions to understand what kind of workloads that they are bringing. Is it a read heavy, write heavy, and what's the data retention that they want? So after they've put up all these questions, one of our engineers go ahead and evaluate and then locate or identify the cluster or the instance for this database. Sometimes we figure out, okay, this is such a massive new database that's going to come to us. We can't co-locate them. We need like a new hardware, like a dedicated hardware for this database. There are other cases where it doesn't, so we kind of deploy them on the existing hardware. So this is the approach that we take. I mean, the turnaround for this is currently taking, I would say, around, I mean, depends whether do we want a new instance or we are going to put it in the existing instance. Existing instance, straightforward. We get like, a PR created by the developers themselves, and then we just merge them and deploy, then wait for our configuration management software to deploy them. So the turnaround is like close to 4 hours, 3 to 4 hours. New instance, that's a different kind of a beast and depends on the hardware availability, etc. But still, I would say it's less than a day turnaround. So much work to be done here. We definitely understood that, okay, this is not on par with some of the other providers, and we need to improve. So that's the first one. When they create the PR itself, they get to pick the database name. That mean they, in the sense, the developers, they choose the database name, they choose the users, different roles for different users. Like some has the service users, which has all the privileges. Then they have like a read-only users. Then they have like a read-write operational users. So they get all those created when we deploy the databases. And then they connect, they have the credentials also, right? Like when they are creating users, obviously they said this goes to Vault, and so they don't have it on their own local machines, and from there they can actually connect to the databases from their local laptops, so they don't have to go through a like a jump box or another like a bastion host. So we use Cloudflare D, like our own product, which provides a tunnel directly to internal to our core network. So that makes it very interesting that people get a seamless experience, that they can just open up the terminal, PSQL, provide the hostname, username, password, and you directly connect to the Postgres database. And we actually wrote a blog about on how to set this up.
And in terms of the journey that you've gone on from when you first started to where you are today, I'm curious if you can talk to some of the dead ends or roadblocks that you've run into, some of the ways that you've been able to lean on the overall Postgres community to help with this, whether that's in terms of actually talking to the Postgres developers or bringing in some of the surrounding ecosystem of tooling and some of the places that you've had to do your own custom development to be able to get to this end state, where I guess it's not an end state, but to the current state of where you are today.
Yeah, buckle up. This is the most interesting topic, I would say. So, to be honest, a lot of them is actually been a lot of these developments are happening because of the stronger or the stricter SLAs and SLOs, right? They are the ones they kind of pushing us that when our organization came and told us that, hey Vignesh, we want the recovery time to be 30 seconds. Can you do that? I was like, okay, I mean, that's a hard challenge. And I have been constant, I mean, my team has been constantly challenged to get that kind of, recovery time or provide that kind of a service. So we can't like really settle for something mediocre. Rather, we have to push. And it's like, necessity is the mother of invention. So we have to like go back to the drawing board and actually we spent like close to 6 months to just solve this one problem. How do we bring our recovery time to less than a minute? So I can go dig more on this. So the way Postgres, fails and recovers, we use a software called Stolon, which is again an open source software written in Go, which has this typical setup of we have watchdogs or keep alives that are keep checking for all the instances whether they are up or down, and then if there is down, then they promote the synchronous replica or the standby replica to become the new primary database. This is good, but there are some challenges here. We run with synchronous replication, which means at any point in time we should have at least two healthy instances for our services, I mean for our Postgres databases to start accepting any changes, right? Like, because it's the idea of there are two kinds of replication, synchronous and asynchronous. Now, synchronous means that the database needs to replicate its changes to at least to one other instances before giving the acknowledgement back to the client. This provides you, obviously, protection from data loss situations. So we do want that there is no negotiation on the fact that we can have any data loss. So going back to this idea that okay, we have these three database instances located on one region and a primary failed. Great. So now we promote the standby database to become the new primary, but also at the same time, we need another database to be acting as a synchronous replica immediately. If not, then all the DMLs, the inserts, updates, and deletes are going to be blocked. So we use a utility called pg underscore rewind. It's a Postgres utility similar to pg underscore base backup or pg in anything else, pg underscore am check, I guess that's also another utility. So it comes with, the point is, it comes with the Postgres installation. You don't have to do anything. And the interesting fact of pg rewind is it only copies the delta in the data between the source and the destination database. So we rely on this to get our recovery time to be less than a minute. But there was a caveat or a gotcha on the tool in pg underscore rewind. One of the things the pg rewind does is that it's supposed to be only copying the delta in the data, but it also copies all the write ahead log segments in the data directory. So write ahead log segments are basically it's like a append only log where all the database changes first gets recorded in that before the data is actually being recorded in the data files themselves. Again, it's for the durability purpose and pretty much how most of the RDBMS works. So now, going back to the challenge of copying all the write ahead log segments, and imagine if you are keeping like a 1 terabyte worth of write ahead logs. These write ahead logs are really useful if people wants to do point in time recovery, right? Like, because you can, since it's append only log in a synchronous timely manner, you can just store your database and then keep applying all these changes so that you can pretty much go any point in time in the past. So because of this, we keep more write ahead logs. Not only that, write ahead logs are also used for the binary replication for the other region that we have in the across the pond. We use this write ahead logs to ship them. So having 1 terabyte worth of write ahead logs means that pg underscore rewind, instead of supposed to be just copying the delta, it was also copying this 1 TB of data. When I ran the first time pg underscore rewind, it took like 1 hour. And I was like, okay, wait, there can't be 1 hour worth of delta in the data here. It is very, very minuscule. And then I found that pg rewind spent all its time copying write ahead logs. So we understood this problem, and I reached out to Heiki, who is currently the co-founder and co-founder of Nia, also long-time contributor of Postgres. Sent an email that, and who is also the author of pg underscore rewind. So that's the reason why I first reached out to him, like asking that, hey, this is how it is working. Is it really supposed to be this way, or am I misunderstanding it? And then he acknowledged that, okay, this is, there is an improvement here. We can do this. So we went back to the Postgres source code, spent 2 weeks, and patched the change and sent it upstream. It's still there upstream. It is not yet merged. That's probably in one of my checklist items, that this for the next version, that we do want to get that merged, because we now have that patch running in our environment now close to a year, and we have seen that working like charm every time. So every time now a server goes down, all our failovers and everything happens, and our services are back within a minute. And this is possible because of this patch that we have made in pg underscore rewind, and possible because of the tool first pg rewind and then this patch on top of it.
And I know from looking at one of the presentations you gave on the work that you're doing that you're also relying on load balancing and connection pooling for being able to handle the scale out aspect. And I'm wondering if you can talk to some of the scaling considerations that you've had to deal with as far as multi region, failover, managing some of the latencies of replication, and some of the work that you've had to do in that load balancing tier to customize to your use case.
Yeah, definitely. That's another interesting, right? Like this is where it goes back to like, hey, people are, we are all hearing about the new distributed system based database. They seems to be the, like solving this internet scale or web scale challenges. Should we use them or should we use Postgres? And as I said earlier, we were able to stretch to a good extent of just using plain old Postgres. So the first way that how we scaled out is by obviously by having multi-region, so that if you have a request, especially a read-only request that comes from a different region, then we can just forward that request to the local region. Again, we have only one primary database, so anything that needs to write still need to go across the ocean or wherever to go to that particular primary. This is in one of my list, that at some day that we will have a multi-primary database. But the support, or right now it's much more challenging to do that in Postgres. And again, that's also, to be honest, not a requirement to a most part of the application. They don't really need a multi primary situation. So the scaling out by region wise is very good to begin with. Then within the region itself, that we have to scale out, right? Like, because you have like, you can only get like so much big box. At some point you are going to hit the ceiling that, okay, that's it. We don't Another interesting thing at Cloudflare is that we also don't run on any specialized hardware. This is not the hardware like custom built for Cloudflare. This is the hardware that you can buy yourself by going to the vendor's website, and you can put in like, hey, I want this spec, and you get the rack, and then you can just spin it out on your own. So building it out on custom commoditized hardware means that we need to scale out. The very first or the straightforward way is by adding more support for read replicas, because, and also 80% of our workloads is in general read heavy. Only 20% of the workload is actually the write portion. So we can scale out by adding more replicas with even within a single region, which is great. Now comes, this is where the load balancing thing comes in. Okay, now you have like five replicas and one primary database. How do you make sure that your connections are spread out equally across all these five databases? Well, we obviously use HA proxy, and that's one of the talks that I gave at HA proxy conference last year in Paris, on how we use HA proxy to kind of load balance the read-only traffic. Then it gets more interesting, right? Like, okay, well, now you got like a primary database and five replicas. Then obviously there is going to be some lag, because all of them is transferring bits and bytes over the network, which means there is a replication lag. Do you want stale data to your clients, or do you want like a fresh data to the clients? So then again comes back to the fundamental question, what's the SLA, right? Like if someone is signing up for it and then we immediately send them to a replica and the data is not there, and if you tell them that your account is not created, that's not a good user experience. So this is where the read after write problem comes in. So in those scenarios, we have to stick to the primary database where we do know 100% that data is there. But we made some smart things. We have to abstract all these things away from the end engineers or developers. This is where the developer experience comes in, and they don't want to be thinking about all these things like a read after write. Should I do this here, or should I be just reading from replicas? And we have added like health checks that, hey, if you have like, if your replica is unhealthy, don't send connections to that replica, because obviously it's going to fail. Then the other one that is silently going to fail is the replication lag. If your replica is lagging by say a minute, meaning that last 1 minute worth of data is not yet there on that replica, then we take that out of the pool automatically. So whenever a client connects to that read-only endpoints, they are always being guaranteed to find the real-time data. So that's where we use HA proxy.
And in your work of building this platform, what are some of the most complex engineering and architectural challenges that you've had to address, and some of the ways that the organizational structure has either helped or hindered that effort?
I would say it's helped a lot. I couldn't even think of one case where the organization has hindered us that day from doing something. Architectural challenge, I would say it's in general the nature of just managing and operating databases is hard. To be honest, like not for since that our team does it, but it's kind of like it's under the radar for the most part because it's behind, it's way beneath the stack, so no one really sees it, and so it doesn't really get the kind of visibility that rest of the stack gets. But in general, we have so many examples in the recent past. You can see that cloud providers trying to do this, trying to roll there on their own, and they're realizing that, oh wow, it's just a lot challenging than just maintaining them. Nothing fancy, just provide an like a, production ready operational database environment and keep the SLAs and SLOs. If you do that, my kudos to them, because I have the empathy on how to, I mean, how hard it is to just to do this. With respect to the challenges, I mean, nothing unique about it. I mean, obviously we have, it's a distributed systems problem. Like, we have to now think about, what is, how does our systems are going to behave if they can't talk to our, let's say, the metadata system, right? So you have this the health checks that are running against each database instances, trying to find, okay, what's going on the instance itself. But they also all maintain the state in a metadata, which we use in our case, it's etcd. So a lot of times they're like, what do we do if they can't even communicate to that etcd? Do they going to make some, weird decisions, or they are just going to, like, just wait? Then interesting things comes in sometimes. Networking is always a fun thing to account for, like different ways it can fail, and we need to always look out for how is it going to fail and how the systems are going to behave. And also, do we want like a soft failure, or do we want like a hard failure, the failures that are like, oops, it's cut, that's it? Sometimes that actually may be much better than kind of the soft failure where your systems are kind of semi healthy and started behaving really weird. So all this is fun challenges, I would say. In terms of how the organization really helped us is embracing this idea of of failures are common. We need more failures. We have to go through more failures to really find success, right? Like, we aren't like really scared of touching things, right? For example, like, one of the requirements is that we want to be rebooting all our database servers once a quarter. It's like, don't do that. Like, if it's running, don't touch them. So that used to be the status quo. And organization pushing the teams to like go on challenging that is kind of really beneficial. So we even actually wrote a custom software called PG Monkey. It's like the chaos monkey but for Postgres. So what it does is pretty much goes ahead and restarts services in a random order. It goes again and restarts this load balancing software that we were talking about some time ago. It goes and does a failover, and it goes and, let's say, restarts, I mean, reboots the mission. We still need to do that. So many of these kind of chaoses that we know kind of happens sporadically, but we kind of like expediting them using our kind of a chaos tool. It's not yet open source. That's one of the things. Currently it's more hard coupled, right? Like hardly low, hard coupled with our setup, so that it's not yet ready for open source. But the idea is here. I'm happy to talk more, and hopefully people can implement their own version and to fit their own systems. And so these things are enabling us to think about failures, learn from them, and then go back to the drawing room and fix it. Not only that, even within the organizations, we do this kind of like a disaster recovery practices, right? Like, don't wait for them. Simulate your disaster recovery and make sure your SOPs are ready. Make sure your systems are behaving as you said it will be. So we practice those. So overall, thanks to the organization in helping us build a solid platform. And also thanks for supporting us when things fail.
This episode is brought to you by Datafold, a testing automation platform for data engineers that finds data quality issues before the code and data are deployed to production. Datafold leverages data diffing to compare production and development environments and column-level lineage to show you the exact impact of every code change on data, metrics, and BI tools, keeping your team productive and stakeholders happy. Datafold integrates with dbt, the modern data stack, and seamlessly plugs in your data CI for team-wide and automated testing. If you are migrating to a modern data stack, Datafold can also help you automate data and code validation to speed up the migration. Learn more about Datafold by visiting dataengineeringpodcast.com/Datafold today. in order to be able to run these database systems at the scales that you're talking about, there are a number of additional layers that are required beyond just that core database engine. I'm wondering what your sense has been from going through this exercise of ways that the database engines themselves can or should be evolved to remove the necessity of those extra layers, or some of the lessons that you've learned from going through this exercise that can also be translated into environments where teams are using a database as a service such as RDS or one of the other providers that is still valuable despite the fact that they're not dealing with the physical hardware underneath.
Yeah, that's an interesting question. So, what are things that can be part of the core Postgres itself, so that just managing and operating it will be more easier? If I can summarize that question, Postgres is really unopinionated on this topic. Doesn't really provides you a guideline or tells you, in the documentation that here is your backup tool you want to use it, or here is your failover tool that you want to use it. No. And or even like connection poolers, right? One of the things Postgres is notorious is, creating a new process, Linux process for each connections, and it doesn't scale, so you have to use a connection pooler. There are right now like a 6 different connection poolers on the market. Which one do you use? There is, right, to be like, I mean, it's fine. I mean, I understand, because these things evolve, and a community recommending one thing strongly is not the best thing. Rather, just they putting out, the pros and cons of each one and letting the consumers pick is, to be honest, the way to go. But that always creates more confusion amongst the newcomers, or even for the old timers. We go through this process that, hey, Patroni is the amazing project, that why are you folks still sticking to Stolon? I'm like, yeah, sure. I mean, it is definitely good, but we made Stolon to work the way we want. Right now, us moving to another platform is not an easy task. That's like a year or two worth of, commitment that we are trying to put. And Patroni is going to come with its own challenge that we don't even know what it is. So rather, I would spend my time and energy trying to get the existing platform, the one that we know, or at least we think we know about it, to learn more about it, rather than going and using something new as it's coming up. So that's going to be a challenge. I don't really think any easy solution for it. In terms of what are the other things that can be part of the core, is this performance, is this multi-tenancy challenge that we have been chatting about. Any kind of observability that we can add would be a really good value add, right? Like, because as more and more systems are going to be cloud based, which means that more and more people are like, been packing. So what cloud, Postgres can provide kind of insights that make it so easy to kind of enable. But other than that, I mean, I don't think anything else. I couldn't think of anything else that Postgres can roll it on its own to make it easier. Like backups, I mean, we have to still do them. This multi-primary, probably one thing that would be interesting, right? There are some improvements that's happening. So you can today, right now in Postgres 16, one can use logical replication, and then they can basically set up as two primary database and then replicate the data between them. So it's coming. It has its own challenges, but it's not, I wouldn't say it's a Postgres challenge. It's the fundamental challenge of which data is you should be considering as source of truth if you have multiple systems, and you, the owner of the data, should know that better, or you have to define, I mean, you have to build your systems accordingly. I don't think anyway magically that Postgres will come and solve. So
And talking about the different versions of Postgres also brings up the question of version upgrades and some of the ways that you're approaching that and how you manage that complexity in this 100% uptime environment that you have to support.
thanks for bringing that up. Yeah, I missed it in the previous one. So that's an area that Postgres definitely can do a better job than MySQL. MySQL had this way of, like, you can upgrade your databases. You have the primary and bunch of slaves, and then further, bunch of replicas, and then bunch of further replicas down. And then you can, like, upgrade from the bottom up, right? Like, you can upgrade your replicas, keep going, and then finally just do a failover, and voila, your entire system is now upgraded. Even today, Postgres doesn't support that, especially if you're running in streaming replication. There are, there are, chats around how we can do this using logical replication, but logical replication itself is not the best solution if you're like really thinking on the scale. So it's good, but not yet they're ready for the prime time, for the scale that, that internet scale that we are talking about. So definitely PG underscore upgrade or Postgres upgrade is the area that we need improvements. Postgres is also going to be releasing a new version every year now. The life cycle has changed. Now 17 is going to come next year. So which means people are going to be upgrading more and more often, and we need some tools. There are a lot of chats I can also link afterwards that, people, community has been start thinking that, hey, how can we improve? The cloud does, even the cloud providers takes like a hard downtime, that we have to do this upgrade like for a minute or two. How do we do like is approach that you can do this your Postgres upgrade with zero downtime? Nothing else is there, nothing out so far is there. We have actually, our upgrades are right now taking up to at least close to a minute or two. And we are also going to actually share in the next month or so on how we are doing the Postgres upgrades. Spoiler alert, we have tweaked the rsync process. We kind of faking the rsync to be more smarter. If you just do like like a dumb rsync, it would be taking like hours and hours, because this is like 10 terabits databases. So we tweak rsync in such a way that we can able to rsync the databases in under less than 2 minutes. So a blog will be out, and hopefully we can also share our entire run book on how we are doing the Postgres upgrades.
In your experience of building this system supporting Cloudflare to be able to manage their different database workloads and the developers who are building on top of this, what are some of the most interesting or innovative or unexpected ways that you have seen the business using these new capabilities, or some of the interesting or unexpected ways that you've seen your team address the challenges that you're faced with?
Sure. Yeah. I mean, the multi-region is, to be honest, interesting one, because we started multi-region for disaster recovery purpose. It wasn't meant to provide this kind of, like what the new paradigm of edge computing, right? Like you throw something in multiple places and now you have like what you call wireless edge computing. That wasn't the intention when we started like 4 years ago or 5 years ago. We needed multi-region because one region itself can go down, like a disaster can take out a complete region. So we put that, and then people started thinking, well, we can actually make our application, much faster. Like we can reduce the latency if we can just go ahead and start using them. That's a good. I think I like, how applications started, utilizing some of the resources that we have. We started using Postgres as a queues, right? Like earlier it used to be a dedicated queue based softwares, sidekicks and etc. Rather now Postgres, it's a Postgres table itself can act almost like a queuing system. Where else we use Postgres as the BI, business intelligence purpose, where we have like a dedicated set of, Postgres instances where we give the access to the analysts and data analysts. They go and run their, weekly queries or monthly queries, quarterly queries. So we don't have a separate like a data warehouse system. So Postgres is our warehouse system too. So yeah, these are some of the interesting ways I found it interesting.
And in your work of building this system, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Interesting lessons is that I think don't give up. Don't settle for, average. Let's say, if you have a strong requirement, and keep challenging yourself. So that's when we able to achieve the reducing, that recovery time objective that we are achieved by basically looking at Postgres source code. Other things we are also trying to do is, another example is that we're trying to reduce our backup restoration time, right? Taking backups is one thing, but how fast you can restore when there is a real need is altogether a different thing. So we constantly pushing ourselves that how do we reduce that recovery time even from a failure. For example, like somebody dropped a table. Now you go back in your production system, get the data back as soon as possible. Or someone ran a delete statement without a where clause, so now the data is gone on in all your transactional systems. Now you have to somehow restore and recover. So there are so many areas to improve, and we are trying to improve. But I think the point is that we don't have to settle for average. Like keep your options open. Chat with people when you don't know, right? Like there's nothing shame on this. I used to feel like, oh, can I ask them? Like, no problem. This example, the anecdote that I shared kind of opened up me that hey, if you do the homework and then go ahead and hit the people who have worked on it, they are more than happy most of the times to just help you whatever you need. That's my key takeaways.
And so, for people who are considering whether or how to invest in the ways that they manage databases for their engineers and for their organization, what are some of the cases where building a platform, even on a fraction of the scale that you're dealing with, is the wrong choice?
Oh, this is the wrong choice. I mean, I'm a supporter of rolling things on your own. So I'm biased. I even have like a pet project called Spin Up, which is an open source version of RDS. So I have been always an advocate of telling people that you don't have to use them, I mean, unless you really have a good reason why you need to use. So I will put it, answer it in another way, that you have to use. I mean, you have to roll up your own, solutions, unless there is a specific reason that you don't need to. So other than that, that's the default I would like to see, because of one, the autonomous, that we talked about, that it provides you, right? Hey, patch your own software. Don't consider your software as like a black box. I mean, at the end of the day, it's code. Even if you can't code, you have team members who can help you code, right? Like that's the fear that I have seen, that, oh, okay, I can't, I mean, I'm not really a developer, software developer, how can I go ahead and fix? That's fine. Part of the problem is actually understanding the problem and then explaining it to someone, that what the problem is. The actual fix itself is like probably a 50 lines or 100 lines of code, which you can rely on a C programmer or a Go programmer who can just come and help you up. But can you get up to that point? Can you actually find some interesting problem, first of all, right? So all this, if you can do, people are ready to help you out. So go with the autonomous options, which is what I really prefer. And also it gives you freedom in terms of also like adding extensions, for example, right? Like Postgres has this rich ecosystem of extensions, and if you are using any other providers, you are waiting, you are on their mercy to support that. Like, hey, when am I going to get this new extension that is really cool, or when is this extension going to be get upgraded? You don't have an option now, you are waiting on them to do it. Then third one is more, I really like the, the freedom that it provides, that you can go, you can really see, this is more of my engineer hat. It's like, hey, I like this kind of systems where I'm not like abstracted layer and layer layer and layer on top of it, and then I've just been given like this minimized version that I can just do this thing. Trade-offs there, obviously. I'm not saying that everyone should go ahead and do it, but at least just spend your time to learn all this, layers. So it really helps in terms of, as being a better engineer. So that's overall how I think about rolling things on your own compared to using a other provider. And also another thing I've recently noticed is that people are now more and more excited about people who are actually building things from fundamental, right, like first principles, than just let's say using a cloud provider. So I see there is this kind of enthusiasm that, okay, we can do this, let's do it on our own, right? So, and there is always the open source community that's behind, right? So if you, even if you have struggling with something to do a complex thing that a cloud provider provides, you can start an initiative and people are ready to chime in and kind of provide you support. So
And so, as you continue to build and evolve and iterate on the platform that you're supporting for Cloudflare, what are some of the things you have planned for the near to medium term, or any particular problem areas or projects that you're excited to dig into?
and developer experience, we acknowledge the fact that hey, there is more we can do on this area. And to be honest, it's kind of a fairly still evolving area, right? Like we haven't really talked about companies that are coming out just to improve the developer experience. Like, hey, what are we doing here? How are we differentiating developer experience? That wasn't the case earlier. I mean, you have to do things like fundamentally that I have to store data, or I have to move bits and bytes, that's your network, or you have to secure something, that's where all the security company comes in. And then in the recent last 4 or 5 years, there are companies which are like, what do you guys do? Like, well, we make it more nicer for the developers to build on top of us. They can also do it on their own, but this is our the go to market. Overall, this entire field itself relatively new, and that's where some of our challenges, we haven't spent that much time on looking at that aspect. Improving on the way how developers connect and communicate with databases. Provide them enough knobs that it's still flexible, but abstract them in such a way that they don't have to deal with every single minute details, that, oh, how does this, how do I do this, how do I do, that's all abstracted, so you don't have to really worry about all these things. That's the fundamental area. I can go back and like, hey, put two other three other projects for the next 3 to 5 quarters and just work on improving developer experience. PG upgrade is super critical, right? Like, we talked about it. Another one is the voice upgrade. So Postgres relies on the glibc, the C library version, on how it does the sorting and collation. And every time you're doing a major version upgrade of the voice operating system, whether it's a Debian or whatever voice, if you do that, your indexes can go corrupt, because the way how it sorts data between different versions of voice is going to be changed. It can have like duplication of data. Your unique indexes can have like duplicate data. Bad problems, like not the problem that you really want on your database. And really, to be honest, that's another burning area, that people have so many threads going on in the hacker list, that hey, how do we address this problem? Again, fundamental challenge, but we need a solution for this, right? Because these things are not going to get any better in 10 years from now, right? Like, can we say somehow that magically that Linux and other innovations going to happen, and then we are not going to have this problem? Not really. PG upgrade, will it get any better on its own in 10 years? No, not really. So we have to go back, even do these fundamental things on providing a good roadmap for how are we going to do the upgrades, how are we going to do the voice upgrades. And we specifically, my team is working on a kind of an SLA, even for that upgrades to be happening in a more periodic way, right? It's an internal systems way, so people have like, much more negotiation power than compared to dealing with an external vendor, that who they're just going to pick a date and they're just going to do it. We understand our nature of business and more accommodative, and that leads us to kind of, little bit do a catch up in terms of upgrades and maintenances. But automating it, part of it, is going to make it so much easier, that hey, we have the systems ready to go, we have a template, let's talk and address the challenges, and then let's do. So two areas that I'm currently excited and looking to improve more.
Are there any other aspects of the work that you're doing at Cloudflare or the overall space of running Postgres as a service that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, I mean, some of those interesting aspects that are still coming out, and we are trying to, understand how Postgres is going to evolve, right? The one of the things is Postgres extension ecosystem. That's just blowing up right now. Like, for example, you can run machine learning workloads on Postgres. So, just kind of like Postgres is now becoming this the platform. So that's one of the aspect I find it interesting. I mean, obviously the serverless aspect that's gaining more and more adoption, and also this idea of that, more workloads in Postgres. So Postgres is stretching further and further out. So look out for that.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
For biggest gap for toolings in terms of data management, that's interesting. I think it's still the fundamental challenges is what I think about, in terms of gaps in data management. Like taking backups and restoration is hard. Like there are tools that I came out, etc., but not like none of them can made it like a breeze, right? Like, hey, I how do you provide this kind of like a near instant point in time recovery, that you drop a table, no problem, within a minute you can just go back to that. Can any of the tools currently today do that? As far as I know, no. So data management problems still going back to this fundamental challenges of how do we kind of back up. Other things like, I would say PII masking, right? Like in terms of how do we provide some kind of masking, and provide you a solution that you can still have like a hopefully a single source of truth, but also different people gets to see or view differently. And third one is that how do we use the same data for different purpose? For example, like we have like a OLTP workload, right? That's all the Postgres is. But there is a requirement that comes in, hey, now we want to, add this looker, or some kind of, BI tool on top of it. So obviously now the question is that, so now are we going to put a new system just to support this, or are we going to keep using the existing one? Right? Again, pros and cons for both, and we mostly pick one of them and we stick to them. But in general, these problems are not yet solved. Like, it's hard. If you fork or, copy your data, Well, now you have two places of your copy. How do you keep them in sync? How do you manage them? How do you set up the backup recovery of failure or high HA for that system? Okay, no, don't do that. Keep it in the same place. Well, your one query from the dashboard is basically going to bring down your entire oltp system. How do you avoid that? Overall hard problem. So yeah, so that keeps me up and more excited about the space, and looking forward to each day to learn from everyone.
Well, thank you very much for taking the time today to join me and share the work that you're doing at Cloudflare to support their database workloads. It's definitely a very interesting problem, interesting approach that you've taken. So I appreciate the time and energy you've put into the work that you're doing there and sharing it with us. Thank you again for that, and I hope you enjoy the rest of your day.
Yeah, thanks, Tobias. I mean, community is a really, really huge part, especially the open source. They need community. They rely on community. So happy to help all the time. So thank you.
Thank you for listening. Don't forget to check out our other shows, podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.